All right, so in this problem, we're going to go over sample question number 26 from the Society of Actuaries ExamP list of sample questions. All right. The probability that a randomly chosen male has a blood circulation problem is 0.25. Males who have a blood circulation problem are twice as likely to be smokers as those who don't have a blood circulation problem. So calculate the probability that a male has a blood circulation problem given that he is a smoker. All right, seems pretty simple. So let's first figure out what the question's asking of us, and then we'll jot down kind of our givens, right? Kind of like a high school physics class, college physics class also, any physics class. So let's see. Calculate the probability that a male has a blood circulation problem. So I'll denote C as having a circulation problem. So probability of C given that he is a smoker, given S. Okay, that's what we're looking for. And like any conditional probability situation, this is going to be equal to the probability that you have a circulation problem and you're a smoker divided by the probability you are a smoker. So let's look at what the question actually gives us. So the probability that a randomly chosen male has a blood circulation problem is 0.25. So probability of circulation problem is 0.25. And if you either have a circulation problem or you don't. So the probability that you don't have a circulation problem should be equal to 0.75. Now, this is where the wording can get a bit confusing. It was when I first read it. Males who have a blood circulation problem are twice as likely to be smokers as those who do not have a blood circulation problem. And what that's saying is the probability that you are a smoker, given that you have a blood circulation problem, is equal to twice the probability of being a smoker, twice as likely to be smokers as those who do not have blood circulation. So that's twice the probability of being a smoker given you don't have a blood circulation problem. Okay, so now how can we use this information? This will be some version of a Bayes theorem problem. So let me just kind of throw this into a chart, see if I can make sense of it that way. So when I'm given stuff like this, where you either have a circulation problem or you don't. You either are a smoker or you're not. I like to make this sort of chart rather than a Venn diagram or a graph or any other sort of visualization. Right? Here I'll put you have a circulation problem, you don't. And that means this row should add up to 0.25, right? If these are the individual probabilities of each possibility. And this should add up to 0.75. So let's say you're a smoker and you're not a smoker. Okay, so the probability, okay, so let's say the probability that you are a smoker given that you don't have a circulation problem, so probability that you are a smoker given that you don't have a circulation problem, let's say that's equal to X. That means the probability of being a smoker given you have a circulation problem is equal to 2x. And I can start filling in my chart using that information. So let's see. So of all the people that don't have circulation problems, right? The probability of all of these people, of them being, of any one particular person being a smoker, is equal to X. So that should be 0.75 X. And that makes sense because if we take a look, the probability of being a smoker given that you have a circulation problem is equal to probability of smoker and having a circulation problem over the probability that you have a circulation, that you don't have a circulation problem, right? I multiplied this over to the other side. So that means the probability of not having a circulation issue times the conditional probability, smoker given no circulation issue, is equal to the probability of the intersection of smokers and people without circulation issues. That's what this box is, right? It's that intersection. And this box here is also this intersection. That's the way this kind of chart's made up, right? So I just multiply those values together to get what's inside this box. Therefore, this box should be 0.75 minus 0.75x. And I can similarly use the same things here, right? So the probability that you're a smoker given that you have a circulation issue, so that should be 0.5 x, right? That's 2x times 2.5. And this box here, the intersection of not being a smoker and having a circulation issue, is just 0.25 minus 0.5x. So now it's asking us, of all of the people that have that are smokers, so of this whole column, what is the probability that you're in the intersection of smokers and those with the circulation issue? So these guys. And that is equal to, let's see here, 0.5x over 0.5x plus 0.75. Right? Hopefully that's that can be seen there, right? It's this divided by the probability of being a smoker. And x there, right, sorry. And I can eliminate these x terms and then plug this into my calculator, right? So that is 0.5 in the numerator and 0.5 plus 0.75 in the denominator, and that gets me 0.4 or 2 over 5. Okay, answer choice C. Now that's, one way of doing it based off a chart. However, if, you're not so used to the visualization, you can go from, instead of going to a chart, you can go straight from here to plugging in a, the Bayes theorem formula, right? And I'll just quickly do that to the side to illustrate both techniques. So from Bayes theorem, I can go from here, and I'll write this to the side there. My numerator would be the probability of someone being a smoker times the probability that you're a smoker given that you have a circulation issue, over the probability of being a smoker. Now, what are the options? Either you're a smoker with circulation issues or a smoker without circulation issues. We need to account for both possibilities. So that would be the probability of being a smoker times the probability you're a smoker given you have circulation issues. Sorry. This is incorrect. This should be the probability you have circulation issues times the probability you're a smoker given you have circulation issues. Same thing down here. Then this is added to the probability. Now you either have circulation issues or you don't, right? So probability that you don't have circulation issues times the probability that you're a smoker given that you don't have circulation issues. And that accounts for both possibilities, right? And we have all of those values. Circulation issues and not circulation issues. That's right here, right? Smoker given you have circulation issues, smoker given you don't have circulation issues. We've determined that right here. So that gives you two different ways of solving this sort of problem. Hopefully that was clear. Hopefully it illustrated, different methods of getting to the same answer. I think both methods are equally easy. same level of difficulty. It's not that one's more efficient than the other. It's whatever you can most easily work with, and that might be a personal preference thing. For me, it really depends question to question. But that's up to you to kind of figure out. Try both out when practicing. Different practice, unless you're doing like a timed practice test. Try out both methods. See if you can, anytime you see a problem, see if you can do it in a bunch of different ways. That'll help you just kind of understand the concept better. And that's, I think, the cool thing about math, right? But that's not what this video is on. If this video helped you, hit the like button or subscribe. That definitely helps me out. If you have any questions, throw it down in the comments. I'll answer them to the best of my abilities. If you want to see more videos of worked out sample solutions, I have a playlist. Check that out. But other than that, good luck, guys.